First things first, ako ba ay naririnig niyo ng maliwanag, clear, on your end? Heart react kayo kung yes. Alright, thank you. Tatapang niyo naman umutan dito ano, day before midterms tas magkakapis ng lesson na hindi naman gano'n ka-related. Anyways, wait lang mag-share screen ako para meron tayong whiteboard. Ayan. So ang ating lesson for today ay about transcendental functions. And you might have heard of it. Nagde-derive na nga kayo nito actually. Transcendental functions. Ano ang transcendental functions? From the word itself, transcend. Ito yung mga functions na hindi kayang ma-represent ng algebraic combinations. What do I mean by that? Kunwari, we have sin x. You cannot make a counterpart of this function using like polynomials like x squared plus x cubed, something like that. Ayun yung mga transcendental functions. Pero hindi ito limited sa mga trigonometric functions. Din tayong hyperbolic functions, meron tayong inverse, meron tayong, uy, pangit naman ang x ko. Meron tayong logarithmic functions, meron tayong exponential functions, something like that. And meron din tayong hindi diyan nagtatapos yung mga transcendental functions, nabubulol na ako eh. Meron din tayong mga tinatawag na gamma functions, error functions, pero that would be way beyond our scope for today. So hindi muna natin siya i-discuss. But for now, we are going to focus on these two functions, logarithmic and exponential functions. So, logarithmic functions. Ano ang logarithmic functions? This is basically another way of looking at exponents. And this is how we engineers deal with small or large quantities. For example, sa inyong general chemistry, 'di ba, you've dealt with pH scales which which is related sa dami ng mga hydrogen ions na nandoon sa mixture. And hindi lang din 'yun ang application ng logarithmic functions, ginagamit din siya sa carbon dating, sa mga radioactive decay, sa acoustics, yung pagpupuwesto ng mga frets sa guitar, ginagamit din siya dun. So, wait nga lang, sulat ko nga lang. Another way of looking at exponents. And you have been doing this
Fast forward.
for quite some time now. For example, 2 raised to 5, ang ibig sabihin lang niyan ay you are going to multiply 2 by itself 5 times. So 2 times 2 times 2 times 2 times 2, 32. Mga ganun lang. 2 raised to 0 equals 1. 2 raised to negative 1 equals 1 half. Ngayon, what does logarithm tells us? If you rewrite these equations into its logarithmic form, you would end up with something like this. Aris, anong nangyari? So from this makikita mo kung anong gustong ipahiwatig ng mga logarithm. Kung makikita mo ang mga exponent, yun yung naging result, yung base, yun din yung naging base. And yung result ng exponent, yun yung naging tinatawag na argument ng logarithm. So basically, ang gustong itanong ng logarithm ay, for example, meron tayong logarithm of 32 base 2 is equals to 5. Ang gusto niyang iparating, anong exponent ang dapat taglay ng 2 para makapunta sa 32? And that would be 5. For the same reason, we can ask the same question with logarithm of 1 base 2 is equal to 0. This equation is asking, anong exponent ang dapat taglay ng 2 para makapunta siya, para makapunta siya sa 1. And again, based sa mga lessons exponents, anything raised by 0 is equal to 1. Therefore, this is 0. Alright? Naka-follow ba ako ng karamihan? Heart react kung yes. Alright, salamat kayo diyan, Lloyd. Wait, ano nga ba? Ayun, ang next kong ang next kong itatalakay ay ang mga tinatawag na properties of logarithms. Ano yung mga properties of logarithms? Ito yung mga laws na pwede nating i-apply para mas simplify ang equations at so that we could perform operations on logarithms. For example, sa ating sa ating exponential expressions, kapag meron tayong, for example, x squared multiplied by x cubed, di ba meron yan ay x raised to 2 plus 3. Ito ay isang property ng exponent. And when it comes to logarithm, we also have properties na parang ganito lang. Actually, dahil nga ang logarithmic functions is another way of looking at exponents, or more specifically, they are the inverse of an exponential function. Sinasabi na kapag nag-add naman tayo ng dalawang, let's say, wait lang, nakalimutan ko lagyan ng base. Kapag nag-add naman tayo ng dalawang logarithm, let's say, logarithm of p plus logarithm of q, ang sum nila ay equivalent sa logarithm of a p multiplied by q. So how does this relate to our exponential function right over here? As you can see, kapag nag-multiply ka when it comes to exponents, mag-a-add. At dahil nga, once again, ang logarithmic functions ay inverse ng mga ganitong functions. Kapag nag-add ka naman, pagmumultiplyin mo yung argument. What does that mean kapag let's say division? 'Di ba kapag nagde-divide ka ng isang term raised to an exponent with the same term raised to another exponent, yan ay equal lang sa difference in their exponents. 'Di ba? X raised to the difference in their exponents, or in this case, x raised to negative 1. What does this imply in terms of logarithm? Kapag tayo ay nagsusubtract ng logarithm, Ba't plus? 'Pag plus yung nilalagay? Yan, 'pag tayo ay nagsu-subtract ng logarithm, sila naman ay ipagdi-divide mo. Yung mga argument ay ipagdi-divide. Ayan. So, we've been making quite some properties now, pero ito ba talaga ay tunay? Let's see. Ano kaya magandang number? Ano? Let's say meron tayong consider logarithm of 5 base 5, and this is equal to what? This is equal to 1. Bakit? Kasi this is basically asking what exponent ang dapat taglay ng 5 para makapunta sa 5. That is just 1. Kaya ang nakalagay dito ay 1. And then, same base. Let's say we have logarithm of 125 base 5. Ano ang magiging result nito? Can someone tell me in the chat kung anong magiging, sige, si John Lloyd.
Hello po. Yan, di ba? 5 times 5 25 times 5 times 5. Is that 3?
Okay. Very well. Ang logarithm of 125 base 5 ay 3. Bakit? Kasi again, ang dapat taglay na exponent ng 5 para makarating sa 125 ay 3. 'Di ba? 5 times 5, 25. Times 5, 125. And let's say gusto nating ipag-add itong dalawang 'to. Logarithm of 5 base 5 plus logarithm of 5, logarithm of 125 base 5 is equal to 4. Anong tinutukoy nitong 4? Ito ay basically, 'di ba ang result ng exponent ay yung taglay na exponent ng 5 para makarating sa isang specific number. Dito naman kapag ang alam natin dito ay yung result na kaagad. So ito ay 5 raised to 4, which is 5 times 5 times 5 times 5, which is this is 25, this is 125, and this is 5 625. So this is similar to saying that we have logarithm of 5 base 5 plus logarithm of 125 base 5 is equals to the logarithm of 625 base 5. As you can see, anong nangyari sa mga argument na mga logarithm natin dito sa kaliwa ng ating pinag-add? 'Di ba parang pinag-times lang silang dalawa? 5 times 125, 625. And with that, we are able to prove this property, that logarithm of p base a plus logarithm of q base a equals logarithm of the same base. Tapos yung argument, yun yung product of the arguments ng pinagsama mong logarithms. Ngayon, try naman natin dito sa property na to. Logarithm of p base a minus logarithm of q base a equals logarithm of p over q. Let's say we have logarithm of 125 base 5 minus logarithm of 5 base 5. And again, ang logarithm of 125 ay 3, ang logarithm of 5 ay 1, Kaya 3 minus 1, ito ay 2. Ano ang wait, sasabihin ko ulit. Ayun, ano yung dapat laman ng logarithm? Ba't base 2 ano? Base 5 to. Ano ang dapat argument ng isang logarithm kung ang kanyang result ay 2? Again, dahil alam na natin ang result, 'di ba itong result lang ay tumutukoy sa exponent ng base. So 5 raised to 2, ang nandito sa loob ay 25. Therefore, ang difference ng dalawang logarithm na 'to minus logarithm of 5 equals logarithm of 5, 25. And again, what do you notice upon observing this operation? As you can see, ang argument ng isang logarithm, then yung argument ng isang logarithm. Yung i-minus mo, yun lang yung naging divisor doon sa isa pang argument. Medyo malabong pagkakasabi. But anyways, ang nangyari dyan, yung isang argument yung naging numerator, yung isang argument yung naging denominator. Just like what we did in this. The logarithm of p base a minus the logarithm of q base a equals the logarithm of p over q base a. The same thing happened here. Logarithm of 125 plus logarithm of 5. Tas napapunta dito yung 125 and then nasa ilalim na yung 5. So far, we have been able to derive two properties of logarithms. We have the addition property, which states that, alam mo, kopyahin ko na ano. Ayan, meron tayong addition and subtraction. Now, what about multiplication? Again, we can think of it in terms of being an inverse with exponential functions. So anong property of exponential functions ang nag-i-involve ng multiplication? 'Di ba, for example, meron tayong x raised to a and then lahat ng yan ay raised pa sa b, then that would be x raised to a multiplied by b. Pinag-multiply yung dalawang exponent. Ngayon, ano naman ang mangyayari kapag nag-multiply ka ng dalawang logarithm? You just reverse the process. From multiplying these two things, naging power sila. So for example, meron akong constant, let's say 2 and then logarithm of 3. Lagyan muna natin ng base. 2 logarithm of 3 base 2. This would be equivalent to logarithm of 3 raised to 2 of base 3. You see what happened there? Kapag nag-multiply ka, kapag nag-multiply ka, magiging powers yung mga pinag-multiply mo. So in this case, 3 yung argument kaya gano'n pa rin siya and then yung naging power ay yung iminultiply mo siya. Kaya kaya, ayun naging power siya ng argument sa loob. Isa pang example, hmm, ano kaya? 25 logarithm of 5 and hindi masyadong malaki pala. Gawin na lang natin 3. 3 logarithm of 5 base 5. This is equivalent to logarithm of what? Again, sinong makakapagsabi sa akin kung ano yung magiging argument ng resulting logarithm? Or ano yung magiging kapalit ng question mark na ayun, recap. Kapag tayo ay nagmu-multiply, kapag tayo ay ito ay multiply ha, ito ay similar sa 3 times logarithm of 5. And kapag tayo ay nagmu-multiply with logarithms, yung iminultiply natin sa logarithm, yun yung magiging base magiging exponent ng logarithm na yun. So in this case, ang iminultiply natin ay 3, so ito ay magiging logarithm of 5 raised to 3. Ano yung 5 raised to 3? Di ba calculate natin yung kanina? Ang 5 raised to 3 ay 125. So, 3 logarithm of 5 raised to 5 is equals to logarithm of 125 raised to 5. Ayun, ah, yung property of multiplication when it comes to logarithms. Again, isa pa. Hmm, let's say 1/2 logarithm base, mali. Logarithm of 4 base 2. Sino makakapagsabi sa akin ng argument ng resulting logarithm? Or yung may question mark ulit sa tawag doon kanan. Ayun, pwede nga pala kayo mag-chat. Dali, ayun, dahil bagong concept yung inintroduce ko kasi nagkaroon ng fraction diyan. Ang mga ginagamit ko lang na example kanina mga whole number lang, 2, 3. But the same rule applies even if this is a rational number. Yung i-multiply mo sa logarithm, yun ay magiging exponent ng nasa loob ng logarithm. And if you evaluate this, again, kapag nag-raise ka ng isang bagay to 1/2, that is just equivalent to saying that it is under a square root. So, this is similar to saying logarithm of the square root of 4 base 2. So, ano to? This is just logarithm of 2. Nakakasabay pa ba so far? Or may 4 po yan. Or may gusto kayong i-clarify? Okay, wala naman so far. Ano pa bang ano? Magbibigay ako ng problem. Start tayo sa pinakasimula nating tinalakay, kung ano yung ipinapahiwatig ng logarithms. Let's say we have logarithm of 8 base 2. Ano yung kanyang result? Or you can also phrase it like, anong exponent ang dapat taglay ng 2 para makarating sa 8? Sige, John Lloyd.
3 po.
3. Okay. So far, so good. Let's say, hmm, ngayon, sa fraction naman yung nasa loob, anong anong exponent ang dapat taglay ng 3 para makarating sa 1/3? Anyone? Puwede kayo mag-chat. Yun, this is -1. Kasi ang exponents once again hindi lang siya it could be all sorts of numbers, 'di ba? It could also be negative. And in this case, 'di ba kapag meron tayong negative na exponent, napapapunta lang siya sa denominator and then i-evaluate mo kung ano yung value ng exponent nun. In this case, 1 lang naman, kaya 1/3. Therefore, -1 ang kailangang exponent ng 3 para makarating sa 1/3. Eto, same idea. Log of 1/4 base 2. Let's say ano pala, 1/8. Sino makakapagbigay ng ano, ng sagot? Ayun, again, this is actually -3. Kasi once again, ang ating exponents, it could also be negative at kapag meron tayong 2 raised to -3, once again, kapag negative ang iyong exponent, ibababa mo lang siya sa denominator. So, meron kang 1/2 cube. Ano ang 2 cube? Ang 2 cube ay 1/8. I mean ang 2 cube ay 8. Therefore, ang result natin ay 1/8 at ayun ang hinihingi. Kaya -3 ang ating sagot. Let's say ano, meron naman tayong logarithm of 2 base 4. Sino ang gustong mag-try ng magiging sagot dito? Sige, John Lloyd.
Hindi ka po 1/2.
1/2, correct. Bakit 1/2? Kasi kapag
Ah,
ang 4 in-erase mo sa 1/2, this is similar to taking, the square root of 4, which is 2. Yun yung destination natin, di ba? 2. Kaya 1/2 ang naging sagot. Hmm, let's say meron akong logarithm of 9 base square root of 3. Ano sa tingin niyo ang sagot nito? Try ulit. Puwede kayong mag-ano sa chat box. 2, malapit na, konti pa.
3 po.
Hala, ba't 3?
Joke lang po pala. Joke lang.
Pero hindi. If you write it this way, 'di ba, ang base natin, this is just 3 raised to 1/2 kasi 'di ba naka-square root. So anong kailangan i-raise mo dito para maging 9? It would be 4, 'di ba? This would be 4. Bakit siya 4? Kasi 'di ba rule of exponents kapag, ah, yung isang exponent ni-raise mo pa sa isang exponent, magmumultiply lang yung dalawang yun. And 1/2 multiplied by 4, that is just 2, and it is equivalent sa 9 kasi 3 squared equals 9. Therefore, ang sagot natin dito ay 4. Isa pa. Same logic. Log of square root of 2, I mean log of 8 base square root of 2. Sige nga John Lloyd, ano, tawag dun, redemption. Ano sa tingin mo sagot dito?
Wait lang po. Diba raise to 1 how? 2 raise to 1 of, nag-result sa 8. That
Yep,
4?
4, final answer na yan?
Sige po.
Sige, try natin kapag 4.
Sige lang po. 4
Kapag ito ay
raising
4,
to,
ang magiging
raising to
exponent lang ng 2 ay 2
2.
kasi magka-cancel ta's magiging 2 'to.
6? 6 pala.
Pero malapit na.
6 po, 6.
Kaya ayun, ang tamang sagot dito ay 6. Kasi kapag again, minultiply mo yung exponents, meron kang 2 cube. And that is indeed equivalent sa 8. 2 cubes is equal to 8. I hope nafa-follow naman kung anong gusto iparating ng mga logarithm ito, mga log. Kasi mamaya ay hindi lang ito ita-tackle natin. We will also tackle kung ano ba yung ln, ano ba yung bakit kapag nag-derive ka ng ex pa rin, ba't kapag nag-integrate ka ng ex pa rin. Those are things that could be explained by simply knowing what logarithms are. Wait, inom lang akong tubig. Okay, resume. Ngayon sa logarithms meron tayong mga tinatawag na conventions. Logarithm conventions. Kapag nakakita kayo ng logarithm na walang base, automatic siya ay 10. Ia-assume na siya na ia-assume ehem, ia-assume niyo wait, take two. Ia-assume niyo na siya ay 10. So this is equivalent to log of x base 10. Anong tawag sa logarithm na 'to? This is what you call common logarithm. Kasi 'di ba, kung lagi mong isusulat ang base 10 in kasi gamit na gamit 'tong logarithm na may base 10. Kung isusulat mo siya palagi 'di ba ang hassle. Kaya we've developed parang shorthand version ng log base 10. Ngayon meron din tayong log base e. This is what you call the natural logarithm. Or you could also rewrite this as ln of x. Natural, n. Logarithm, L. Kaya ln yung kanyang abbreviation. So basically, kapag nakakita ka ng ln x, yun ay parang, hindi pala parang, yun ay similar sa logarithm based time. And then, ano ba yung tinatawag nating e? E is just another constant that exists in nature. What do I mean by that? Kasi meron tayong mga constant na it is just, wala lang, tunay lang. For example, ang ratio ng circumference ng isang circle sa diameter, it is always pi or 3.1415. Dito naman, ang E, it represents natural growth. What do I mean by natural growth? Example, meron tayong isang hindi, gandahan natin ang ano. Meron tayong isang bangko. Ta's meron tayong piso. Tapos gusto mo 'tong i-deposit sa iyong account sa bangko. Tapos let's say, yung bangko na 'to, it's, a miracle bank kumbaga. Kasi lahat ng ibinibigay mong pera 100% interest yearly. So yung perang inilalagay mo or idine-deposit mo sa bangko, dumodoble kada taon. So paano mo yun maka-calculate? That is just A, 1 plus dahil ito ay 100%, ito ay magiging 1 lang din, yung nasa baba. Tapos yung ating rate ay isusulat ko pala muna ang general formula. Ito ay sabihin natin ay ayan. Ito yung perang ininvest mo, ito yung interest rate, at ito ay kung gaano ka kadalas bayaran ng bangko. So let's say nag-invest ka ng piso, tapos ang interest rate ay 100%. So that is just 1 kapag kinonvert mo sa decimal form. And then yearly, let's say 1. So, yung piso mo magiging ₱2, 'di ba? Kasi ito ay 1 plus 1, 2 raised to 1, 2 pa rin, times 1, 2 pa rin. Kaya yung piso mo naging ₱2. But let's say na ang bangko binabayaran ka ng 50% kada 6 na buwan. What would our formula be kung ganyan ang case? Kapag ganyan, edi meron tayong yung starting money natin na A and then plus 1 over 0.5 and then twice ka babayaran kada year kaya ito ay squared. So kapag ito ay 1, kailangan ko nga ng calculator ko. 1 times 1 plus 1 over 0.5 squared. Wait lang, parang may mali yata akong ginawa. Oh. Wait. Ayun, alam ko na kung saan ako nagkamali. Sa formula. Kasi wala pala yung fraction doon. So ayan, anyways, question tayo. Ang 50% in fraction, in decimal ay 0.5 lang. So that is just 1/2. At kapag nilagay mo dito ang 1/2, meron tayong 2.25. So from 1 peso, naging 2.25. But what if the bank pays you quarterly? That is just so 25% yan ay kada 3 months. Diba? So ito ay ilang beses kang babayaran sa isang taon? 4, diba? Kasi 12 months sa isang taon. So meron tayong A, 1 plus, ano yung 0.20? Ano yung 25% in decimal? That is 0.25. And that is just 1/4. So 1 plus 1/4, then raised to 4. Kapag nag-invest ka ng piso, after 1 year, yung piso na yun ay nagiging 2.4414 pesos. So pataas ng pataas. Pero what if, let's say, the bank pays you, tawag dun, every day. So ano mangyayari dun? That would be 1 plus 1 over 300. Ilang days ba meron sa isang taon? 365, di ba? So ito ay 365. 1 over 365 raised to 365. And kapag nag-invest ka ulit ng piso, kapag pinalagin mo sa calculator, yung piso mo ay magiging 2.71456 something. But what if we even make it more extreme na let's say, yung pera mo ay lumalago sa bangko kada minuto? What does that mean? So let's say nag-invest ka ng piso, so yun ay 1 plus, um, gaano kadaming minuto sa isang taon? There are 365 days. There are 24 hours in one day. There are 60 minutes in 1 hour. So yun ay 365 times 24 times 60. And yun lang din ang ilalagay natin dito. So, kapag siya ay aking in-evaluate ulit sa akin, mahiwagang calculator. Meron tayong 2.71828. And as you can see, paliit na ng paliit ang ating rate of increase. Kumbaga dito, nag-raise ka lang ng tumaas ka lang ng 2 beses, 0.2 na kaagad yung difference. Pero this time, sobra-sobra na yung itinaas mo, ang nag-change lang ay 0.004 something. But this, if you continue increasing the numbers, habang ito ay pa-extreme ng pa-extreme, you are getting closer to what we know now as E. This is also called the Euler's constant, if I'm not mistaken. Or Euler's number pala, which is 2.7182818 something ganon. And it is determined dahil hindi naman tayo pwedeng maglagay na lang ng 999999999 diyan, mga sobrang tataas na values. Mathematicians, with their knowledge of limits, have come up with what if i-represent natin yung dalawang to as x and then palakihin natin siya to infinity. So this is a 1 plus 1 over x and then this is x. Ano? Yan. Ito, if we take this limit, it would be just e. Ito yung definition ng e. Wait lang. Dami-dami kong sinabi. Pero nakaka-follow naman ba? Naku, wala nang sumasagot. Baka hindi niyo naiintindihan. Magtanong lang kayo if you want. Ayun, but anyways, hindi naman ganun ka-importante na malaman kung papaano ba na-derive yung E. But let's just appreciate kung how it came to existence. Na siya ay based, actually dun nga siya nanggaling eh. Sa, tawag doon sa banking, dito nagmula ang creation of E. And E can also be found in nature. Most commonly, ang examples dito na related sa E ay population growth. For example, meron kang like 100 rabbits and by the end of the year, hindi lang sila nag-double, it, naging let's say 271 pa yung rabbits. So that is what E represents. Yun yung growth that we usually found in nature. At hindi lang 'to sa rabbits makikita, pati rin sa mga patterns na nakikita natin sa nature, sa mga fractals, sa mga tawag dun, sa structure ng mga puno. But anyways, that is bish that is beyond logarithms. Gusto ko lang naman iparating kung saan nanggaling yung which brings me, parang nasabi ko kanina kung bakit ang derivative ng e raised to x ay e raised to x pa rin. Ang dami kong nakikitang ano, ang dami kong nakikitang ganitong meme sa Facebook kung saan ano, merong pokeball tapos yung gustong kuhanin ay yung e to the x. Tapos use differentiation, it was not very effective. But why is that the case? Let's say meron tayong constant raised to x. 'Di ba kapag nag-derive tayo nito, ito ay equal lang sa a raised to x ln a. Tama ba? Mga nagdi-difficult diyan, tama ba? Ang derivative ng a raised to x. Okay. Tanda ko pa naman. Ngayon ang goal natin, ang derivative dapat ng a raised to x ay mag-equal sa value ng function. So how would we do that? Wait, ayaw gumalaw ng mouse ko. Ayun. We want to find the value of a such that its derivative is equal to its value. So how would we do that? 'Di ba meron tayong ano, first principle of differentiation. The limit as h approaches 0 nung ating function which is a raised to x. Wait, lagay ko muna f of x plus h minus f of x over h. Ito yung gusto nating hanapin. And then yung ating f of x. Ang f of x natin ay simply a raised to x. So this is a raised to x plus h minus a raised to x over h. Limit, ba't mayroong over? Limit as h approaches 0 equals a raised to x. And as you can see, pwede kang mag-factor ng a raised to x sa taas kasi meron tayong common term. Kasi 'di ba, properties of exponents. Kapag meron kang exponent na naka-add to one another, yun ay equivalent lang sa pagmu-multiply sa kanilang dalawa. So ayun, kita na natin na may common term. Limit as h approaches 0. Kapag finactor out ko dito yung a raised to x, meron tayong a raised to h minus 1 over h. Ba't wala loob to? But dun sa other side ng ating equation, meron ding a raised to x. So if we divide both sides, these two would cancel out. And yung matitira na lang dito ay 1 kasi a raised to x over itself ay 1 lang din. So, meron tayong a raised to h minus 1 over h. Meron pa bang simplification dyan? Wala na. But how does it relate to this? Actually, if we take if we can also rewrite this by letting h equals 1 over x, so that x will just become 1 over h. How did that happen? Tinik ko lang yung reciprocal ng both sides. And if I do that, yung x mapapapunta sa taas at yung h mapapapunta sa baba. Kasi nakikita ko a lot of times ang ginagamit ng mga students kapag let's say 1 over b equals a, tapos gusto nilang kuhanin yung value ng b, ang gagawin nila, magmu-multiply pa sila both sides ng b, tapos i-divide nila both sides by mali. I-divide nila both sides by a. But again, dahil nga in algebra, we are only concerned with keeping balance. Kung anong gagawin mo sa kabila, gagawin mo rin sa kanan. So, kapag na-raise mo to -1 yung both sides, ito ay magiging b over 1 over a na kaagad. Ayun lang, that is how I was able to get x equals 1 minus h. So kapag nira-write natin tong limit na 'to, yan ay magiging limit as h approaches 0 kasi nga bawal 'tong maging negative. I mean bawal 'tong maging 0 kasi kapag naging 0 yan magiging undefined kasi infinite. This is going to be 1, ano yung ating 1 over x plus h. Ano yung ating x? 1 over h. And this is similar to what we have here. If we substitute e, at ang ating e ay ito, let's say, copy mo naman. Ito yung ating and it became the value of a. Masyado na pa. We have that. Basically, ang ginawa ko lang ay tinrato kong e yung a and then sinubstitute ko kung ano yung kanyang value. At ang kanyang value ay limit as h approaches 0 of 1 plus h quantity raised to 1 over h. So, if we simplify this expression, as you can see, it would be redundant to write the same limit over and over again. So, pwede natin itong pagsamahin. Limit as h approaches 0 and 1 plus h raised to 1 over h and properties of exponent. Kapag ang isang ah, kapag ang isang term ay ni-raise mo sa isang wait nga lang, ulit nga. Take two. Kapag ang isang term ay ni-raise mo sa h, yung kanyang exponent, igmo-multiply mo lang dun sa h. So, meron kang alam mukhang n eh. Ayan, minus 1 over h equals 1. And kapag minultiply mo 'tong dalawang 'to, it would cancel out. You would end up with 1 plus h minus 1. And kapag pinagsama mo ang positive 1 at negative 1, mawawala lang yung value. And therefore, ang matitira na lang sa atin ay h over h, and that evaluates to 1. At ang limit of as h approaches 0 of 1, dahil wala na tayong variable na h, you can ignore this. And that is just 1 is equal to 1. And with that, we are able to prove why yung value ng a ay dapat e para yung kanyang derivative ay maging same ng value ng kanyang function. Tapos, sa logarithms, meron din tayong graphs. Kasi lahat naman ng function merong graph, di ba? At yung graph, ipinapakita niya lang yung behavior ng function na yun, kung ano yung nangyayari sa y, depende sa kung anong in-input mo na x. So, for example, meron kang, okay, magandang ano. Let's say meron tayong logarithm logarithm of x is equal to y. Again, this is base 10 kasi hindi ko in-specify yung base ng logarithm. This is also called as common logarithm. And one of the best ways to graph logarithms ay number 1, hanapin yung asymptote. Number 3, i-determine yung mga transformations. Ba't number 3 kaagad? Lutang na ako eh. Tapos number 3, ayun, table of values. Kasi kapag tayo ay nag-substitute ng arbitrary values of x, makikita natin kung ano yung ordered pair or yung y na nagko-correspond sa value na inilagay. For example, naglagay tayo ng ito yung ating x, ito yung y. Tapos ang ating function ay logarithm of x equals y. Kapag nag-substitute tayo sa x ng 10, ang logarithm of 10 base 10 is just 1. Bakit? Kasi yun yung exponent dapat ng 10 para makarating sa 10. Kaya siya ay 1. Ngayon, let's say meron tayong ang laki pala ng ibinigay kong ano. Mahirap to i-graph. Let's say ano lang pala, logarithm of x base 2. Ayan, para mas manageable. Ngayon kapag meron tayong 2 as x, the logarithm of 2 base 2, that is just 1. Kapag meron tayong 4, that is just 2. Kapag meron tayong 8, that is just 3. Kapag meron tayong 16, that is just 4. And with that, you can graph the logarithm. kapag ang x ay 2, ang y ay 1. Dito. Kapag ang x ay 4, ang y ay 2. 1, 2, 3, 4, 5, 6, 7, 8. Kapag ang x ay 8, ang y ay 3. Tama ba? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. Okay. And so on and so forth. Ayoko nang i-graph yung 16. Pero meron din tayong 0. And that would be mali pala. Meron din tayong 1 pala. And that would be 0. Ayan. Kasi, again, kapag nag-raise ka ng kahit anong value to 0, ang result niya ay 1 lang din. So, ito ay magiging 1. And kapag tineraise mo siya, you will see that it does this. Ngayon, Aris, bakit hindi nagtuloy-tuloy yung function dun sa kabila? It is because x cannot become negative here. From your lessons in domain and range, kapag meron tayong logarithm, ang domain natin lagi dapat ay yung mga values na pwedeng i-input doon sa ating logarithm. In this case, let's say, nag-logarithm tayo ng negative 10. Ayan ha? This is basically asking, what value should I raise to get to negative 10? And that does not exist. Kahit mag-raise ka ng kahit ano pang, I mean, kahit anong value pa ang sinubstitute mo dito sa question mark na to, or kahit anong value pa ang exponent ng 2, never niyang maaabot ang negative numbers. Hanggang 0 lang siya. I mean, hanggang 1 lang pala siya. Kasi 2 raised to 0 again is 1. So this could be 0, but it cannot be negative numbers. So, if we make an equality with that, x should be greater than or equal to 0. We can make um, a set like that. And this indicates na pwede kang maglagay
So,
ng 0 kahit gaano pa kataas yan to x, but bawal kang maglagay ng negative. It could
allows
be
current to flow from left to right
0.00001, it could be
in
it
its
could be
true state. So, meaning, pinost ko
999,
si X20.
I mean
So, supply siya.
9,999,
Kasi on ko si
but it
conveyor.
cannot be
Namatay siya. Tapos
negative. Kasi
kailangan ko
nga,
pilitin si
hindi
X21
natin maaabot ang
para
negative
ma-push.
numbers
Tapos
kapag
babalik
nag-raise
siya ng
tayo sa
kabila.
isang number. I mean, nag-raise tayo ng isang number to an exponent.
Ulit tayo. Wait lang.
And then,
No project.
ang range naman ay
Program ko
kung
lang siya mabilis. X20.
hanggang saan ang maaabot ng ating
X21.
value.
X7.
Hanggang saan ang
X0.
maaabot ng logarithm of x base 2. In this case, that would be
Tapos,
all real number. All real
sorry guys,
numbers.
baka may naisip ko yung solution for this.
Kasi
You
kapag
can
nagpakababa-baba ka
kindly
sa
check
sa
po.
logarithm, let's say
Tapos,
1 over
nakalink siya kay y0 natin. Then kay
4,096.
y1.
That would just be negative, di ba? Sino ano nga ba pala dito sa
Mm.
calculator? Right.
Tapos,
That would just be negative
ah,
12. So,
gusto natin siyang
as
patuloyin kapag
we can
negative
say
na.
that as x
Tingnan si
approaches
x
0,
0.
as x approaches this,
So, dito naman tayo sa closure.
as x approaches the
So, try
y-intercept,
natin na
it
activate value sa
approaches
x0.
infinity. Pababa siya ng pababa.
Then, direct kay closure na y.
But we can also, um, tawag doon, we can also flip the equation by adding a
Try natin
negative
hindi ilagay si
sign. Let's say,
y0.
meron tayong
So, x0
logarithm
ulit. Tapos nakalagay kay timer na
of x.
t0 kay
Let's
30.
say negative logarithm of x equals y.
Tapos, ito ang ilagay natin.
Ay, may nakakalimutan pala ako.
F9,
I forgot the base.
F7, then
Ito nga pala ay base 2. At kapag nagawa ka ng table of values, ito ang x, ito ang y. Say kapag ang x ay 1, 2, 3, 4. So kapag ang x ay 1, ang logarithm of 1 base 2 is just 0. And kapag ang x ay 2, itong entire thing na to ay magiging 1 lang. So y equals negative 1. And then, if you continue the same thing, kapag ito ay 4, kapag ang x ay 4, ang logarithm of 4 base 2, that is just 2. At kapag ito naman ay 8, ang logarithm of 8 base 2 ay just, nakakalimutan ko negative, kasi may negative nga pala sa labas. Negative 3. And if you graph this, let's see, kapag ang x ay 1, ang y ay 0. Kapag ang x ay 2, ang y ay negative 1. Kapag ang x ay 4, ito ay negative 2. 2, 3, 4, 5, 6, 7, 8. Kapag ang x ay 8, ito ay negative 3. As you can see, finilip lang yung ating graph sa ordinaryong logarithm. Pero meron din tayong tinatawag na transformations. And this applies to every function. For example, meron kang, let's say parabola, y equals x squared. We can shift it vertically or horizontally by just manipulating the values of x and y. So kapag ang y ay minusan ng 4, ang x ay minusan ng 4, then the graph of parabola would be shifted 4 units to the right. But ito yung 4 units upwards and 4 units to the right. So yung vertex niya, magiging 1, 2, 3, 4, 1, 2, 3, 4. Nandito yung magiging center ng parabola. And that is how you shift functions. This is not, hindi lang to na-apply sa parabola. It could be applied in circles, ellipses, lines, basically any conic sections that you could think of, and any functions, including logarithm. So, Let's say, balik tayo sa ating unang equation. Y equals logarithm of x. Kapag ang x ay minusan natin ng, let's say, -2, I mean, minusan pala ng 2, at ang y ay minusan din ng 3 naman, ang result ay magkakaroon ka ng 3 units na shift pataas and then 2 units na shift papuntang right. So kung ang original function nito ay this, okay. Yung mga points dito, it would just shift 3 units pataas and then 2 units pa kanan. So 1, 2, 3. It would be here. Wait, nakalimutan ko yung 2 units pa kaliwa. Kanan pala. So 1, 2, 3. 1, 2, it would be here. And then ganun din sa next point. And then sa next point, and then it would go something like this. Bakit mapaganyan yung graph? Because hindi na nasa y-intercept or x equals 0 yung kanyang asymptote. Ano yung asymptote? Yun yung line na gustong puntahan ng graph mo pero hindi niya maabot-abot. Ang asymptote natin dito ay situated sa value na wala sa ating domain. In this graph, ang ating domain ay it could be 2 and above. Yan ang ating domain. Kasi any more less than 2, let's say kapag ang x natin ay 1, kapag in-evaluate ito ay magiging -1. And once again, hindi pwedeng maging negative ang argument ng isang logarithm because it's impossible. Kaya, ito yung ating domain. Ito yung values of x na pwedeng ma-plug in sa y minus 3 logarithm of x minus 2. Pero by the same token, ang range natin, it is just all real numbers. It could be negative, it could be positive, it extends indefinitely, or it could be also rewritten as negative infinity to positive infinity. That is basically how you graph logarithmic functions. Okay lang. Meron bang questions so far? Any clarifications? Tagal ko nang nagsasalita din eh. Okay. Sure ka, Cassandra, wala kang tanong? Okay, sure siyang wala siyang tanong. And then, now na alam na natin mag-graph, alam na natin ang mga laws of logarithm, at alam na din natin kung ano yung ln, ano yung e. Wait lang, ang dami ko palang natakalan. Ngayon naman tayo mag-start ng pagsosolve ng logarithmic equations. What are logarithmic equations? From the word itself, ito ay equations na may logarithm. Gaya nga lang ng in-example ko sa graph kanina, logarithm of x base 2 is equals to y. This is a logarithmic equation. But, meron ding types of equation kung saan pinapahanap tayo kung ano yung value ng x. But before we delve into that, tayo muna ay magpa-practice sa wait, ayun. We have to practice expanding logarithms and condensing logarithms. Expanding and condensing. Basically, just like what the word suggests, ang pag-expand ng logarithm ay, ayun, pag-expand ng logarithm. So for example, logarithm of uh, a times c times d, it could be also rewritten as ln. Logarithm of a plus logarithm of c plus logarithm of d. Kasi once again, yung properties of addition ng logarithm, yung mga parameters sila, ipag-multiply mo lang lahat. Kaya, this is equivalent. Pero let's say, meron naman tayong logarithm of AC over B. What does that indicate? Once again, apply the property of logarithms. Ang mga nakamultiply sa loob ay naka-plus sa labas. So ito ay logarithm of A plus logarithm of C minus logarithm of B. Kasi siya yung naka-minus doon. But let's say we have logarithm of x over y z. Ano na yung kanyang expanded form? It would be logarithm of x minus. Diba itong dalawang to ay pinag-multiply lang. Tapos siya yung denominator ng x. It would be similar to logarithm of y plus logarithm of z. Diba? Ito yung numerator x, ito yung denominator yz. Alam to isang brackets. And kapag dinistribute mo yung negative sign, meron kang logarithm of x minus logarithm of y minus logarithm of z. Next question. Let's say meron tayong natural log naman. Natural log of x squared plus y cubed. Ano yung expanded form niya? It is, dahil nga multiply, kapag minag-multiply mo yung mga argument, kapag in-expand mo ay magiging plus, ito ay magiging ln of x squared plus ln of y cubed. And then, isa rin, hanap sana ba tayo? Ayun, isa rin sa property ng logarithm na kapag nag-multiply tayo sa isang logarithm, yung i-multiply natin, yun yung magiging power ng argument. How could we apply that here? We could we could do the same process in reverse. Yung power ng argument, pwede natin siyang ilabas at um, gawing nakamultiply sa ating natural log. So this would be 2 ln x. Ilabas ko lang kasi yung 2. And likewise, pwede ko rin ilabas yung 3 dito. So this is 3 ln y. Hmm. Let's say log of 5 log of 5y xy squared over, let's say wz. Yan. Ano yung expanded form yan? This would just be, again, itong mga to ay nakamultiply lang. So, logarithm of 5 plus logarithm of x plus logarithm of y squared and then minus yung ating denominator which is kasi ito ay ano lang naka you can write this as raised to 1/2. So this is similar to having 1/2 multiplied to the denominator. And then, ipagpa-plus lang natin yung nasa loob, logarithm of w plus logarithm of z. Check nga natin kung tama ating mga pinagagawa dito. Ang logarithm of 5 plus logarithm of x plus logarithm of y ay ipagmumultiply lang. So, logarithm of 5xy squared minus 1/2. 1/2 logarithm of w plus logarithm of z. Kapag pinagsama yung dalawang to, it would just be multiplying both of them. And then, kapag nag-multiply ka ng constant sa isang logarithm, yung constant na yun ay magiging exponent lang ng argument. So this is minus logarithm of wz 1/2 and then logarithm of 5xy squared. Ito, ayusin ko nga lang sulat. Logarithm of 5xy squared. And so, wz quantity raised to 1/2 is just equal to it being under a square root. And kapag pinag-minus mo silang dalawa, this would just be 5xy squared over yung ating square root na wz. And this is equal to what we started with, which is logarithm of 5xy squared over wz raised to 1/2. Ayun. But opposite ng expanding, meron din tayong condensing algorithm. Algorithms. Condensing logarithms. And that is just basically what we did when we checked this result. Kapag nag-condense ka naman ng logarithms, as its name suggests, ipagsasama-samahin mo lang yung mga logarithm. For example, meron akong ln of 2 minus ln of x. Ano yung kanyang condensed version? It would just be ln of 2 over x. Diba kapag tayo ay nagma-minus ng logarithms, yung i-minus mo, yun yung magiging denominator or divisor ng argument. So, we have ln 2 over x. Let's say meron tayong 3 ln x minus 4 ln y. Based sa properties na kapag nakamultiply ulit ang isang bagay sa isang logarithm, yung bagay na yun ay magiging exponent ng nasa loob ng logarithm. So this will become ln x raised to 3 minus ln of y raised to 4. At kapag pinagsama mo to, in-evaluate mo tong difference na to, meron tayong ln of x cubed over y4. Yan yung condensed version ng 3 ln x minus 4 ln y. But what if we have 4 logarithm x minus 2 logarithm y plus 1/2 logarithm z? Ano yung magiging result niya? Again, kapag may nakamultiply sa logarithm, yung bagay na yon ay magiging exponent ng nasa loob ng logarithm. So this is logarithm of x raised to 4 minus logarithm of y raised to 2 plus logarithm of z raised to 1 half. At ang z raised to 1 half is just square root of z. At kapag nagsama-sama mo sila, ito ay logarithm of x to the fourth over y squared plus logarithm of square root of z. This will just become x to the fourth square root of z over y squared. Ito yung condensed version ng 4 logarithm x minus 2 logarithm y plus 1 half logarithm z. Okay pa ba, Cassandra? Nakakasunod? Alright. But anyways, let us try evaluating um, let us try solving the value of x of logarithmic equations. For instance, we have maganda example. 2 raised to x minus 1 equals 2 raised to 2x minus 4. Again, meron ditong nifty trick kung saan iti-take mo yung logarithm of both sides so that you could solve for x. So for example, meron tayong 2 raised to x minus 1 equals 2 raised to 2x minus 4. Kapag nag-logarithm of base 2 ako in both sides, kasi nga dapat kapag nag-aalgebra, kung anong ginawa mo sa kaliwa, yun din ang gagawin mo sa kanan. So let's say meron tayong ditong log base 2 tapos 2 is 2x minus 1. Meron tayong ditong log base 2 of 2 raised to 2x minus 4. Again, from the properties of logarithm, pwede natin yung property na ginawa natin dito, pwede natin tong i-reverse. Yung exponent ng logarithm sa loob ay pwede natin gawing nakamultiply sa labas. So, this is just 2x minus 1 multiplied to log 2 base 2. Similarly, we can do that with the right-hand side. So this is 2x minus 4, logarithm of 2 base 2, and then logarithm of 2 base 2, that is just 1. So meron kayo 2x minus 1 times 1 equals 2x minus 4 times 1. And that is just 2x minus 1 equals 2x minus 4. Ay, ba't pala 2x ang nilagay ko dito? X pala to dapat. My bad. Pero anyways, the same process. If we isolate x, if we transpose x here and we transpose 4 here, we would end up with 2x minus x equals negative 1 plus 4. At kapag pinagsama-sama ko lang silang lahat, x will just be 3. So that is our value of x, and that is how you solve for these kinds of equation kung saan nasa exponent yung x. Let's try for another one. Let's say meron tayong 3 raised to 4x minus 7 equals 3 raised to 2x over 3. And again, lahat ng numbers, even if it doesn't have an exponent, I actually raised to 1. And from the properties of exponent, kapag meron kang same base, tapos yung exponent nila ay magkaiba, ipagmaminus mo lang yung kanilang exponent. So this would be 3 raised to 2x minus 1. And this would be 3 raised to 4x minus 7. Using the same method, we can take the logarithm base 3 of both sides. And then convert the exponent or move the exponent outwards. So meron kang 4x minus 7 logarithm of 3 base 3 and then 2x minus 1 logarithm of 3 base 3. And again, this would just be equal to 1. This would just be equal to 1. So, the entire equation becomes 4x minus 7 equals 2x minus 1. Kapag tinranspose ko yung 2x sa kabila, that is 4x minus 2x, at tinranspose ko yung 7 sa kanan, meron tayong negative 1 plus 7. So, this is 2x equals 6. And once again, ang x natin ay 3. If we divide both sides by 1/2. Pero let's say meron tayong hindi naman naka-exponential form yung binigay. Let's say naka-logarithm. 2 plus logarithm of 1 plus x equals logarithm of 1 minus x squared. Ngayon, it would be better na meron lang tayong dalawang terms when it comes to these kinds of equation. So what can we do with that? Itong logarithm, pwede nating i-transpose sa kabilang side. So we would have 2 equals logarithm of 1 minus x squared minus logarithm of 1 plus x. And ito ay similar lang. Diba ang square root ay exponent na 1/2. It could also be rewritten like this. Tapos minus logarithm, 1 plus x naman raised to 1/2. And then that is all equal to 2. Then once again, yung exponent ng argument ng logarithm, pwede mo siyang ilabas, pwede mo siyang gawing naka-multiply sa logarithm itself. So meron tayong 1/2 logarithm of 1 minus x squared minus 1/2 logarithm of 1 plus x. And if we multiply both sides by 2, we can get rid of the 1/2. We would have 4 here, and we would have no fractions dito sa kanan. Okay. Now, pwede natin pagsamahin itong logarithm na to. This would be logarithm of 1 minus x squared, 1 plus x. And as you noticed, ito ay pwedeng ma-factor. And fortunately, isa sa mga factor niya ay nasa denominator. So if we factored it out, pwede mong makancel yung mga bagay-bagay dyan. So this is just 1 plus x multiplied by 1 minus x over 1 plus x. This 2 will cancel and we are left with logarithm of 1 minus x. Ngayon, if we raise both sides to 10, dahil nga ito ay ang common logarithm ay yung base niya laging nasa 10. This will become 10 raised to 4 become 10 logarithm of 1 minus x. Dahil nga, once again, ang logarithm ay inverse ng exponential functions. They would undo each other out, and this would be 10 raised to 4 equals 1 minus x. And if we transpose wait. Wait a minute. Check ko lang kung tama aking ginagawa. 1/2, 1/2, 1/2, and then multiply both sides by 2 and evaluate 1 minus x. And then 1 plus x, 1 minus x, pinaktor. Alright, mukhang tama naman. So, ito ay magiging ang 10 raised to 4? 10,000 equals 1 minus x. And then x is 1 minus 1,000, 10,000. Therefore, x is equals to 9999. However, kapag sinubstitute mo yung x dito sa ating original equation, let's say, kapag nalagay natin dun yung negative 9999999, magiging negative pa rin yung argument. And that cannot happen in terms of in terms of wait, nasa na ba? Ayan. At bawal yung mangyari kapag meron tayong logarithms. Bawal maging negative yung ating argument. Try ko lang i-graph sa decimals itong simulat kong problem. Ayun. It doesn't intersect the x-axis. And what does that mean? It doesn't have no roots. Kapag wala siyang roots, wala siyang solution. And therefore, yung x natin dito ay empty. Empty set. Let's go try another problem. Let's say, similar naman tayong logarithm base 2 of 2 and logarithm base 2 of 3x minus 5. Once again, when working with these kinds of equation, mas maigi kung dalawang terms lang. So how can we achieve that? We can combine these two logarithmic terms. So ipagta-times lang yung kanilang mga argument. 2 times 3x, that's 6x. 2 times negative 5, that's negative 10. and equals mo yan sa 3. Therefore, kapag both sides ay ginawa mong exponent ng 2, these two would cancel out and we have 6x minus 10. What is 2 raised to the third power? That is 8. And when we transpose this to the other side, that would be 6x equals 18. And if we divide both sides by 6, we have x equals 3. That is how you solve logarithmic equations. By now, we have probably tackled like almost all things that you need to learn about logarithms. Kasi naman, meron din ditong tricks na ginagamit sa pag-solve, but that would be for more complex equations. And I would like to reserve that for other meetings. But for today, I would like to conclude our Kapis class. Kuya Lindon, pwede na po pwede na po mag-dismiss? Okay po. Ayun. Thank you po for attending and for making a podcast out of my lesson. Oo nga po eh. Ayun nga po. If I was Kung ako nga po yung nasa kanilang situation, tingin ko nga po hindi po ako mag-a-attend ng Kapis, eh. Kasi may midterms kasi may midterms pa bukas, ang daming aaralin. But anyways, thank you po for listening, and that would be all.